Have you ever ended up with wrong answers while finding solution of an electrical network using nodal analysis? As you know, if there are more number of current sources or if it is a non-planar network, the most appropriate circuit analysis technique to find its solution is none other than nodal analysis. But sometimes when we perform nodal analysis, we get wrong answers. Do you ever think about the reason for that? Alright, in fact, there is a procedure for performing nodal analysis which is to be followed correctly. A small mistake in performing this procedure will lead to wrong answer. So, if you want to perform nodal analysis and get correct answer, keep watching this video because it's all about it. It's me Abhisha. Thank you so much for clicking. It's a concept-based session on nodal analysis. Stay tuned to the session as I'm going to share some tips on how to avoid mistakes while performing nodal analysis. After watching this session, you will be prepared in such a way that you can solve any problem using nodal analysis. So, let's get started. Nodal analysis is a circuit analysis technique based on KCL, Kirchhoff's current law. If you have any doubts regarding KCL, please do watch my session all about KCL. The link of that session is given in the description box. Let me now take you to the procedure for performing nodal analysis in a network. In first step, we have to identify all nodes present in the network. Let me ask you something. Do you know what is a node in electrical network? Any idea? Alright, it's nothing but a point in a network at which two or more elements have common connection. So, to perform nodal analysis, first we are supposed to find out all nodes present in the network. Then, select a node as reference node and label remaining nodes as V1, V2, V3, etc. It is better to select the node with maximum number of connections as reference node. It will help us to simplify the mathematical analysis. After that, we are supposed to apply KCL at each node except at reference node. When we apply KCL at a particular node, always assume that node is at higher potential than other nodes, so that all unknown currents flows from that node to other nodes. In other words, we can say that when we apply KCL at a particular node, all unknown currents should be taken as outgoing current at that node. Got it? Finally, solve the equations obtained after applying KCL at each node. Alright? Do you have any doubts? I think you will get a clear picture when we solve problems. So, moving forward to problems. First question I have for you. For the circuit given below, compute voltage across each current source. You can see the network. Here we have two current sources, 3 amperes and 7 amperes. The voltage across these two current sources are to be determined. For performing nodal analysis in the network, first we are supposed to identify all nodes present in the network. How many nodes are there? Any idea? Here we have 4 nodes. This is our first node, second node, third node and fourth node. This fourth node is taken as reference node since it is having maximum number of connections. Let us label this as node V1, this as node V2 and this as node V3. In next step, we are supposed to write KCL at each node. At node V1, we have one incoming current 3 amperes and 2 unknown currents. The unknown currents are the current through this 1 ohm and that through this 2 ohm. These two unknown currents should be taken as outgoing currents at node V1 when we write KCL at this node. One end of this 1 ohm is at potential V1 and other end is at potential V2. Correspondingly, the outgoing current through this 1 ohm at node V1 can be written as V1 minus V2 by 1. On the other hand, one end of this 2 ohm is at potential V1 and other end is at potential V3. Hence, the outgoing current through this 2 ohm at node V1 can be written as V1 minus V3 by 2. By KCL, sum of currents entering at node V1 is equal to sum of currents leaving node V1. Here we have 3 outgoing currents at node V1. Hence we can write V1 minus V2 by 1 plus V1 minus V3 by 2 plus 3 is equal to 0. It is written here. By rearranging this we get 3 by 2 V1 minus V2 minus V3 by 2 is equal to minus 3, which is labeled as equation number 1. Next, we are supposed to write KCL at node V2. At node V2, we have 3 unknown currents. The unknown currents are the current through this 3 ohm, that through this 4 ohm, and that through this 1 ohm. Since we are writing KCL at V2, all these 3 unknown currents are to be taken as outgoing currents. So we are going to find out expressions of these 3 unknown currents. I think you can pause the video and try to find out the expressions yourself. It will definitely help to improve your confidence. Alright? Hope you all tried it. Now look at this 3 ohm. One end of it is at potential V2 and other end is at reference node at 0 potential. Correspondingly, the current through this 3 ohm from node V2 to reference node can be written as V2 by 3. On the other hand, one end of this 4 ohm is at potential V2 and other end is at potential V3. Hence, the current through this 4 ohm from node V2 to V3 can be written as V2 minus V3 by 4. Finally, one end of this 1 ohm is at potential V2 and other end is at potential V1. Correspondingly, the current through this 1 ohm from node V2 to V1 can be written as V2 minus V1 by 1. Alright? At this node, we have 3 unknown outgoing currents. So we can write V2 by 3 plus V2 minus V3 by 4 plus V2 minus V1 by 1 is equal to 0. So what is our next task? Our next task is to write KCL at node V3. Now, can anybody tell me how many branch currents are there at node V3? At node V3, we have 4 branch currents. One incoming current 7 amperes and 3 unknown currents. 3 unknown currents are the current through this 5 ohm resistor, that through this 4 ohm and that through this 2 ohm. Since we are writing KCL at node V3, these 3 unknown currents are to be taken as outgoing currents at V3. Now let us find out the expression of all these 3 unknown outgoing currents. When you look at this 5 ohm, you can see one end of it is at potential V3 and other end is at 0 potential. Correspondingly, the current through this 5 ohm in downward direction can be written as V3 by 5. Then one end of this 4 ohm is at potential V3 and other end is at potential V2. Hence, the current through this 4 ohm from node V3 to V2 can be written as V3 minus V2 by 4. Finally, one end of this 2 ohm is at potential V3 and other end is at potential V1. Hence, current through this 2 ohm from node V3 to V1 can be written as V3 minus V1 by 2. Thus, at this node, we have one incoming current 7 amperes and 3 unknown outgoing currents. By KCL, sum of currents entering at node V3 is equal to sum of currents leaving that node. Hence, we can write V3 by 5 plus V3 minus V2 by 4 plus V3 minus V1 by 2 is equal to 7. By rearranging this, we get minus V1 by 2 minus V2 by 2 plus 19 by 20 V3 is equal to 7, which is labeled as equation number 3. Thus, we have 3 unknowns V1, V2, V3 and 3 equations. Now, you look at this network. Here we are asked to find out the voltage across all the current sources present in the network. We have 2 current sources, 3 amperes and 7 amperes. By inspecting this network, it is clear that minus V1 is the voltage across 3 amperes and V3 is the voltage across 7 amperes. When we solve these 3 equations, we get our desired quantities as minus V1 is equal to minus 5.23 volts and V3 is equal to 11.47 volts. Alright, that's all about this problem. Let us now solve one more problem based on nodal analysis. Determine the current flowing left to right through 15 ohm resistor. You can see the network here. Let us first analyze this network. Here we have 2 independent current sources, this 2 amperes and this 4 amperes, and 4 resistors. Current through this 15 ohm from left to right is the desired quantity or the quantity to be determined. Here we are going to perform nodal analysis in this particular network for determining unknown quantity. As I told you earlier, for performing nodal analysis, first we are supposed to identify all nodes present in the network. Can anybody tell me how many nodes are present in this network? Just analyze this network and tell me. Here we have 3 nodes. This is our first node and second node, third node. This third node is selected as reference node since it is having maximum number of connections. Let us label this as node V1, this as node V2 and this is our reference node. I is marked as current from node V1 to V2, which is the quantity to be calculated. Now we are going to write KCL at node V1. At node V1 we have one incoming current 2 amperes and 2 unknown currents. The unknown currents are the current through this resistance combination and that through this 15 ohm. As I told you earlier, when we write KCL at a particular node, we have to assume that node is at higher potential than others, or we have to assume all unknown currents as outgoing currents at node V1. Alright? Okay, now you look at this 15 ohm resistor. One end of it is at potential V1 and other end is at potential V2. The current through a resistor can be mathematically expressed as potential difference across the resistor divided by resistance value. Here the potential difference across this 15 ohm can be taken as V1 minus V2. Correspondingly, the current through it can be written as V1 minus V2 by 15. Then these 7 ohm and 3 ohm are connected in series and the current through this can be mathematically written as V1 by 10. Now this expression represents sum of outgoing currents at node V1 and it can be equated to 2 amperes. It is written here. By rearranging this, we get V1 by 6 minus V2 by 15 is equal to 2, which is labeled as equation number 1. What is our next task? Our next task is to apply KCL at node V2. When we scrutinize node V2, we can see there is one incoming current 4 amperes and 2 unknown currents. The unknown currents are the current through this 5 ohm and that through this 15 ohm. As I said to you earlier, when we write KCL at V2, these 2 unknown currents should be taken as outgoing currents at node V2. Now let us find out the expression for these 2 unknown currents. One end of this 5 ohm is at potential V2 and other end is at reference node at 0 potential. Correspondingly, the outgoing current through this 5 ohm at node V2 can be written as V2 by 5. Now you focus on this 15 ohm. One end of it is at potential V2 and other at potential V1. Since we are writing KCL at node V2, V2 should be assumed as greater than V1. Correspondingly, the potential difference across 15 ohm becomes V2 minus V1, and hence the current through it can be written as V2 minus V1 by 15. By KCL, sum of currents entering at a node is equal to sum of currents leaving that node. At node V2, we have one incoming current 4 amperes and two unknown outgoing currents. Hence, we can write V2 by 5 plus V2 minus V1 by 15 is equal to 4. It is written here. By rearranging this, we get minus V1 by 15 plus 4 by 15 V2 is equal to 4, which is labeled as equation number 2. Thus, we get two equations on two unknowns V1 and V2. When we solve these two equations, we get V1 and V2 is equal to 20 volts. Hope you remember, in the question we are asked to find out current through 15 ohm from left to right. It is labeled as I here, which can be mathematically expressed as I is equal to V1 minus V2 by 15. By substituting the value of V1 and V2, we get I as 0 amperes. Alright? Hope you understood this problem perfectly. So, we are at the end of this session. Hope you all enjoyed it. Thanks for watching. Thank you.